Okay, so today we are doing topic 3 of the syllabus. So, alright, let's get straight into that. Okay, so you can see in the Jamb syllabus, topic 3, phenomena of kinetic theory of matter, melting, vaporization, boiling, freezing, condensation, all in terms of molecular motion and Brownian movements. Then the other gas laws. Then we move over to vapor density and relative molecular mass. Okay, so here is kinetic theory of matter. Number 1, all matter is made up of particles called atoms. These atoms and molecules exert attractive forces on one another. The closer they are, the stronger the attractive forces. Number 4, they are in motion, so they possess kinetic energy. Number 5, increase in temperature causes an increase in the kinetic energy. So this is the kinetic theory of gases. Molecules of gases are in constant rapid motion and collide with themselves and the walls of the container. Now they are elastic collisions. These collisions are elastic. 3, the volume of gases is negligible, that is, they take just any volume of their container. 4, the forces of attraction, that is cohesive forces, is negligible. Cohesive means forces between themselves. Forces between gas molecules is negligible. And 5, the average kinetic energy of the gases is a measure of its temperature. That is, a higher temperature will give higher movement of the gas molecules. So the difference between solid, liquid and gas based on these rules. Now a solid has definite shape, a liquid has no definite shape but takes the shape of the container, while a gas has no definite shape too. A solid has definite volume, a liquid has definite volume, but a gas does not have definite volume. Also take the volume of the container. Now a solid has a fixed mass, a liquid has a fixed mass, a gas also has a fixed mass. Okay. Now a solid cannot be compressed, a liquid can also not be compressed, but a gas can be compressed. Compressed means to like pack it up the more. You know that gases just take the volume of the container, so you can compress them into a smaller volume. Now a solid is very dense, a liquid is less dense, and a gas is the least dense, as it is shown on the screen. Okay, so the average kinetic energy of gases is a measure of its temperature. That is, at 100 degrees Celsius, gases will move slower than at 3000 degrees Celsius. Increase in temperature causes increase in the movement. So melting point is a temperature that moves the molecules into a higher kinetic energy that are so high that they break the molecular forces between them and go into a liquid state. So when a solid is being heated up and the molecules move to higher kinetic energies that they break the solid bonds and turn into a liquid, this temperature is called the melting point. So the heat needed to do this is called the latent heat of fusion. So welcome to vaporization. So vaporization is simply when a liquid that it is now heated up and then it gives off gases, that is, the molecules move to kinetic energies that break the liquid bonds and turn into a gas. So this is called vaporization. So vaporization has to do with boiling and then evaporation. So both boiling and evaporation are related to vaporization. So what are their differences? Boiling happens at only one temperature, that is the boiling point, but evaporization happens at all temperatures, but an increase in the temperature will cause increase in vaporization. Okay, the rate of vaporization increases with the increase in temperature. Now boiling happens throughout the liquid, that is, the whole liquid boils, but evaporation only happens at the surface, only at the surface that gases are giving up. So the rate of evaporation is lower in electrovalent compounds. Why? They are more bonded together, so they have less tendencies to form gases than in covalent compounds that are loosely bonded compared to electrovalent compounds. So this is because electrovalent compounds have greater forces of attraction. Now this heat needed to convert a liquid into a gas is called the latent heat of vaporization. Now saturated vapor pressure, at this point the rate of condensation equals the rate of evaporation. The rate at which the vapor turns into a liquid equals the rate at which liquid turns into the gas, so it's at equilibrium. Now boiling point, this is the temperature at which the vapor pressure of the liquid equals the atmospheric pressure. At normal boiling point, the saturated vapor pressure equals 1 atm. That is 100 degrees Celsius for water is at 1 atm. That's the normal boiling point. But if you change the atm, you can see that the boiling point also changes. So that 100 degrees Celsius you have ever known is the normal one. Why? It's because it is at 1 atm. Condensation: when the gas loses its kinetic energy to a much cooler body and becomes a liquid. That is a gas turning to a liquid. So when the gas touches a cooler body, that's the spoon, and the kinetic energy is reduced and turned to a liquid. Now freezing: when a liquid cools into a solid form. So at freezing point, the liquid and the resulting solid are at equilibrium at the same temperature. So the liquid at 0 degrees Celsius at equilibrium with the solid it forms at 0 degrees Celsius. At critical temperature, a gas cannot be cooled by pressure alone, and this pressure level is called critical pressure. These are useful things to note. So here are the gas laws. The first is Boyle's law. The volume of a given mass of gas is inversely proportional to the pressure, provided that the temperature remains constant. So V is inversely proportional to P, as you can see, and this K constant is temperature. So if you solve that, we have PV is equal to K and P1V1 equal to P2V2. So this method is used to solve for any pressure or any volume that is missing. Okay, so this is a question of Boyle's law from Jamb 2008. You can pause the video to read the question properly before checking the solution. So P1V1 is equal to P2V2. Please pardon the camera quality, it will be better in the further calculations. So P1 is 800 millimeter mercury, V1 is 300 centimeter cube. Sorry for writing millimeter mercury. P2 650 millimeter mercury, and now V2 is not known, so that's what we are looking for. So we substitute the values into the formula. P1V1 equal to P2V2. So 800 for the P1 multiplied by 300 for V1, which is equal to 650 for P2 multiplied by V2, which we do not know. So by mathematics rules, we divide both sides by 650, and we have V2 as 800 multiplied by 300 divided by 650. So what we have as our answer here? So the answer is 369.23 centimeter cube. Chauchat's law: the volume of a given mass of gas is directly proportional to the absolute temperature, provided that pressure remains constant. Okay, that is V volume is directly proportional to temperature, provided that this K constant is pressure. So which can be put as this: V1 T1 is equal to V2 all over T2. Okay, so you can use this to solve for any volume or temperature that is missing. So please, you can pause the video to check the question before checking the solution. Okay, please do that. So first you write out the formula. V1 is 28.8 centimeter cube, T1 is 18 degrees Celsius, which I convert to Kelvin. V2 is also V2 is not known. T2 is 0 degrees Celsius, convert to Kelvin, which will be 273 Kelvin. So to convert degrees Celsius to Kelvin, you simply add 273 to degree Celsius. Okay, add 273 to whatever value you have in degrees Celsius. You have Kelvin. So first I substitute the values of T1, T2, V1, leaving V2 behind, and then I'll be able to solve out what V2 is with mathematical methods. So I have the answer as 27.3 centimeter cube. So Graham's law of diffusion: the rate of diffusion of gases is inversely proportional to the square root of its density, provided that the temperature and pressure is kept constant. Represented as this, and density can be replaced by the molar mass, that is the relative molecular mass, which can also be written as this. Then you know that rate is volume over time, so rate is 1 over time. So you want to replace rate here with time now, is you have to reverse it. So T2 will come to the up, T1 will come to the down, and the other part remains the same. So let's see how this works in the question. Please pause the video so you can read the question properly before checking it. Alright. Okay, so you know that R1 over R2 is equal to root M2 over M1, right? Now this M2 is also known as the molar mass or the relative molecular mass. Alright. Now we know that relative 2 times vapor density will give you relative molecular mass. So since vapor density of oxygen was given as 16, so 2 times 16, 32, that will be the relative molecular mass of oxygen. Now for chlorine, we have the vapor density as 36. If you multiply that by 2, you have 72 as the molar mass of chlorine. So now you can fix that into the formula. So you know that rate is volume over time here. Now you can see that they gave us volume and they gave us time for one instance. So we have to replace volume over time into the equation. That is R1 will be equal to V1 over T1, R2 will be equal to V2 over T2. So now let's see how we can replace this into this equation. So now I replace R1 with V1 over T1 and V2 over T2 into R2. We know that M2 is chlorine. That is the second one, the second compound they mentioned. So that's why chlorine is 72 and oxygen is 32. Okay, so it can also be simplified to V1 T2 all over T1 V2. Okay, so that is your simplification. So now you can see that, oh sorry, oxygen is 32 there, not 36. That was a mistake. So V1 is 30, that's for oxygen. T1 is 7 seconds. V2 is 60, that is for chlorine. Okay, and it's T2 that is missing here. Okay, so I'm trying to change this. This is 32, sorry. So this will be 16. So I break that further. I have 18. Okay, I have 9 over 4. So 30 times T2, 7 times 60, we have 9 over 4. So we have this. Now root 9 over 4 will give me 3 over 2. So now we have to find T2, the time to take chlorine. Okay, so now what do? By normal mathematics, we use the denominator to multiply the top, that is to multiply 3. Then we go over and we find T2 as 21 seconds. Is it there in the option? Yes. Okay, so Dalton's law of partial pressure. In a mixture of gases which do not react chemically together, the total pressure is the sum of the individual pressures each gas will exert if it alone occupies the volume of the container. That is, the total pressure is equal to the individual pressures that each gas will have if that was the only gas in the whole volume of the container. So volume A containing volume A in the container alone, volume B in the container alone, and volume C in the container alone, their individual pressures is what will give you the total pressure of this gas. Hope you get the point. Okay, so mathematically it's written as the total pressure is equal to partial pressure of the first gas plus partial pressure of the second gas plus partial pressure of the third gas. Now you want to find the partial pressure of the first gas to be the mole of the first gas divided by the total mole, that is mole 1, mole 2 and mole 3 of the third gas, and this is called the mole ratio. Then you multiply that by the P total. Okay, so you can write down these formulas out to get your head around them. Okay, you can please pause the video to check the question before looking at the solution. Okay, so that of oxygen, okay, that of hydrogen is 20 centimeter cube. That of oxygen is 35 centimeter cube. That of carbon dioxide and so on and so forth. Now you're asked to find the mole ratio of hydrogen. Okay, so normally you will have just found the mole of hydrogen, then divided by, find the mole of hydrogen divided by the total mole, that is the mole of the first one, mole of the second one, mole of the third one. Okay, so this was the formula we got from the Dalton's law of partial pressure. Now this N1 over N1 plus N2 plus N3 is the mole ratio. That is, divide the mole of that substance by the total mole. Okay, but here now we are going to use volume instead, but you can convert these volumes to mole to calculate them. It will still give you the same thing, but for quicker solutions you can just use volume instead. and it still give us the same thing. So the volume of the gas we are looking for divided by the total volume of all the gases. So 20 for hydrogen, divide everything by 20 for hydrogen, 35 for oxygen, 15 for carbon dioxide, 10 for nitrogen. So if you sum that up and you divide it, what are we going to have? We have 0.25. Is it in the answer? Yes. So that is the mole ratio of hydrogen. Okay, so the next is general gas law. This law combines Boyle's law and Charles' law as follows. So Boyle's law, we have PV is equal to K, that is PV is constant. Now in Charles' law we say that V over T is constant. Now we say PV is constant and we say V over T is constant. Now if we combine these two together, what we have is PV over T is constant. So this is just the general gas law. So the general gas law states that in any given mass of gas, the ratio PV over T is constant. P1 V1 over T1 is equal to P2 V2 over T2. Please pause the video to share the question properly before checking it, right? So how do you know a question is general gas law? Is when it uses the three parameters pressure, volume and temperature. So here V1 was 30 decimeter cube and they said it was an STP. STP means standard temperature and pressure. Okay, so now as standard temperature and pressure, the pressure and the temperature is a constant, and at STP the pressure is 760 millimeter mercury or 1 atm, that is the pressure, while the temperature is 0 degrees Celsius, which is also 273 Kelvin. Okay, so I replace that there to get a P1 and V1. Now they said that what volume will it occupy at 91 degrees Celsius and 380 millimeter mercury. So that will be P2 and C2. Okay, so with that now I convert 91 degrees Celsius to Kelvin by adding 273. So with that now I put it into the parameters to find the volume it will occupy, that is the V2. So by solving by normal mathematics, then I will have my desired answer. So with this now we have V2 as 80 decimeter cube. Is it there? Yes. Okay, so this is the ideal gas law and it's depicted by this equation where PV is equal to nRT. P is the pressure, V is the volume, N is the mole, R is the molar gas constant, which is 8.31 joule per mole per Kelvin, and T is the temperature. Now please pause the video to check the question. Alright, so now you are given pressure in atm. So if it's in atm, R is equal to 0.082, but if it's in millimeter mercury, that's when you use 8.314. okay, so if it's in atm, you use 0.082 for R. If it's in millimeter mercury, you use 8.314. okay, now the volume was given to be 10. The mole is what we're looking for. We have gotten our R already. We convert the temperature given to Kelvin and then we substitute to calculate it. So we put 4 for pressure, 10 for volume, and we calculate normally mathematically, and then what we have as our mole is 0.89 mole. Is it there in the options? Yes. So molar volume, 1 mole of a gas is 22.4 decimeter cube. This is what is called the molar volume. That is, 1 mole of a gas contains 6.02 times 10 raised to the power 23 atoms, and this number of atoms in a mole is what is called the Avogadro's number. Now what is vapor density? Vapor density is the number of times the mass of a particular volume of a compound or element is heavier than the mass of equal volume of hydrogen. That is mass of X volume of the compound over mass of the same X volume of hydrogen. So mass of 1 mole of a compound is divided by mass of 1 mole of hydrogen. So now you know that 2 atoms of hydrogen make 1 mole. Now the 2 times the mass of 1 atom of hydrogen will give you that. So if we use the 2 to multiply the top, you have 2 times vapor density is equal to this. So the mass of 1 mole of a compound divided by the mass of 1 atom of hydrogen will give you 2 times vapor density. Now remember, the mass of 1 mole of a compound is the relative molecular mass. The mass of 1 atom of hydrogen is just 1 gram. So you can see that it's still the same thing as the relative molecular mass. So we have relative molecular mass is equal to 2 times the vapor density. So 56.00 centimeter cube gave us 0.11 gram. Okay, now what is the vapor density? That was the question. Now vapor density is the mass of that volume of a compound, certain volume of that compound, mass of certain volume of X divided by mass of equal volume of hydrogen. So now what do? Now we have to find the mass. Now 22.4 decimeter cube is 2 gram of hydrogen. That is the molar volume of hydrogen. That is in 1 mole, which is 22.4 decimeter cube. We have 2 grams of hydrogen. Since hydrogen is diatomic, that is 1 times 2 will now give us 2 grams for 1 mole. So we already know that 22.4 decimeter cube gave us 2 grams. But now the top one is in centimeter cube and we have decimeter cube here. So we have to convert 22.4 to centimeter cube by multiplying it by 1000. So we have 22,400 centimeter cube. Give us 2 grams of hydrogen. Then what will 56 centimeter cube give us? So with that, now we'll find the respective mass of hydrogen by normal mathematics. Then what do we have there? So what we have as the mass of hydrogen is 0.005 gram. Okay, so that's the mass that is contained in 56 centimeter cube. Okay, so what we do here is to use the normal vapor density calculation method, which is the mass of that certain volume of hydrogen, that is the mass of 56 centimeter cube of X, divided by the mass of 56 centimeter cube of hydrogen. So the first one we have 0.11 gram and that of hydrogen is 0.005. So if we divide that now, what do we have as our answer? Okay, our answer is 22. So that is the vapor density and it's right there in the options. But there's also another way to solve this. So that's what I want to show you now. Okay, so since 56 centimeter cube gave us 0.11 gram, now we know that 2 times vapor density is equal to relative molecular mass. So we can solve this another way. If we have the relative molecular mass, we can divide it by 2, right, to get vapor density. Yeah, so now that's what we are going to do for this method. So now we know that relative molecular mass is also the molar mass. Okay, that is mass of 1 mole of the substance. Now the molar volume is 22.4 decimeter cube, which is also 22,400 centimeter cube. So if 56 centimeter cube gave this, 22,400 centimeter cube will give us what? So what we're trying to do here is to find the molar mass of this particular compound, that is the mass in that molar volume. So what we do is by normal mathematics, and then what do we have here as our X? So X will now be equal to 44 gram. So divide 44 by 2, which is the relative molecular mass, you have 22 as the vapor density. Video, if you love this video, don't forget to hit the like button and subscribe to this channel. Bye. Thanks.